And the crazy part is, something like 87% of machine learning models never make it into production. 87%. All that research, all that data, all that compute, just sitting there.
Wow, 87%? That's staggering. I knew the number was high, but not that high. Where's that figure coming from?
Various sources, but Gartner and VentureBeat have both cited similar numbers. It's a persistent problem, and it's costing companies a fortune. Think about all the potential revenue left on the table, all the efficiency gains missed.
It's not just about missed opportunity, is it? There's the sunk cost, too. All that investment in talent, infrastructure, and data, effectively wasted. So, why are so many models failing to launch? What's the disconnect between the lab and the real world?
Exactly. That's the million-dollar question. It boils down to a few key areas. First, there's the gap between research and engineering. Data scientists are often focused on model accuracy, while production engineers are worried about things like scalability, reliability, and latency. It's like building a beautiful race car engine but forgetting to design the chassis and suspension.
That makes sense. So the data scientists are optimizing for a specific metric in a controlled environment, but that metric might not be the most important one in the real world, and the engineers are left scrambling to make it all work. But surely companies like Google and Meta have figured this out.
You'd think so, right? But even they've stumbled. Think about some of Google's research projects that never became widely adopted products. They have amazing research in areas like AI ethics and fairness, but how much of that actually makes it into the core products like search and ads? It's a huge challenge to translate cutting-edge research into robust, scalable systems.
Okay, so that's one problem, the research engineering divide. What's another major pitfall?
Data drift. This is huge. A model trained on historical data might perform brilliantly in the lab, but as soon as it's deployed, the real-world data starts to change. Consumer behavior shifts, new competitors emerge, economic conditions fluctuate, and suddenly your model is making predictions based on outdated information. It's like trying to navigate with an old map. You might start in the right place, but you'll quickly get lost.
But aren't there tools for monitoring data drift? I mean, it's a well-known problem.
There are, but monitoring is only half the battle. You also need a robust system for retraining your model on fresh data, and that's where things get tricky. You need automated pipelines, version control, and rigorous testing to ensure that your new model is actually an improvement over the old one. Think about Netflix. Their recommendation engine is constantly learning and adapting to your viewing habits. They're not just using the same model they built 5 years ago. They're continuously retraining and refining it based on real-time data.
Okay, continuous retraining. That makes sense. So, research engineering divide, data drift. What's the third big reason why ML models fail in production?
Lack of proper infrastructure. This is often overlooked, but it's absolutely critical. You can have the most accurate model in the world, but if you don't have the infrastructure to support it, it's going to crash and burn. You need scalable compute resources, robust data storage, and reliable networking. Think about a company like Uber. They're processing millions of ride requests every day, and their ML models are making real-time decisions about pricing, routing, and driver assignments. They need an incredibly sophisticated infrastructure to handle that kind of load.
So, it's not just about the model itself, it's about the entire ecosystem around it. The data pipelines, the deployment infrastructure, the monitoring tools, it all has to work together seamlessly.
Exactly. It's like building a skyscraper. You can't just focus on the design of the building itself. You also need to worry about the foundation, the plumbing, the electrical system. Everything has to be integrated and optimized.
This is all fascinating, but I think a lot of engineers might be thinking, okay, this sounds complicated and expensive. Is it really worth it? Especially for smaller companies with limited resources.
That's a fair question, and here's where it gets interesting. The biggest mistake companies make is treating ML as a separate project rather than integrating it into their core business processes. They think, we'll build this model, deploy it, and then magic. But ML is not magic, it's a tool, and like any tool, it needs to be used strategically.
So it's not about building the best model, it's about building the right model for the specific business problem you're trying to solve.
Precisely. And that means starting with a clear understanding of your business goals, identifying the key performance indicators you want to improve, and then designing your ML model to achieve those goals. Think about Amazon. They're not just using ML to recommend products, they're using it to optimize their entire supply chain, from forecasting demand to managing inventory to routing deliveries. It's deeply embedded in their core operations.
Okay, so what are some practical things that software engineers can do to improve their chances of getting their ML models into production? Let's say someone is listening to this and thinking, I want to make sure my next ML project doesn't end up on the shelf. What should they do differently?
Three things. First, embrace the MLOps mindset. Think about your model as a piece of software that needs to be continuously developed, tested, and deployed. Automate your pipelines, version control your models, and monitor your data for drift. Treat your ML models with the same rigor you would treat any other critical piece of code.
That's a great start. What's the second thing?
Second, start small and iterate. Don't try to build the perfect model on day one. Build a simple baseline model, deploy it, and then iterate based on real-world feedback. It's like the MVP concept in software development. Get something working, get it in front of users, and then refine it based on their behavior.
Makes sense. Don't boil the ocean. What's the third and final actionable thing?
Third, collaborate with the business team. Don't work in a silo. Talk to the people who will be using your model, understand their needs, and get their feedback throughout the development process. Remember, your model is only valuable if it's solving a real business problem. Think about Stripe. They're working very closely with their users to understand their pain points and then build ML models to address those pain points. For example, they use ML to detect fraudulent transactions and prevent chargebacks.
So, to recap, embrace MLOps, start small and iterate, and collaborate with the business team. Those are three concrete things that engineers can do to increase the odds of getting their ML models into production.
Exactly. And remember, it's not about building the most complex or sophisticated model. It's about building a model that delivers real business value. Think of it as the Goldilocks principle of ML. Not too complex, not too simple, but just right.
The Goldilocks principle of ML. I like that.
So remember, don't let your cutting-edge AI gather dust. Get it out there and let it start solving real-world problems.
The best model is the one that ships.